Yeah, Madan sir, you can start. Madan sir?
Yeah, ma'am. Shall I, ma'am?
Yeah, you can.
Yes, ma'am. Very good afternoon to one and all present here. We all are very familiar about the free resource of Ministry of Human Resource Development virtual lab, which is vlab.co.in, in which I am going to give a demo about basic structural analysis laboratory, in which there are some list of experiments like analysis of simply supported beam, continuous beam, column, portal frames, arches, etc. Out of these experiments, I am going to choose continuous beam experiment, in which I am going to show there are two span continuous beam, in which while applying a point load as well as UDL, what is going to happen, especially the shear force and bending moment category. Before that, there are some basic conditions and criteria is given in this, like stress, strain, Young's modulus, everything is given with the unit of measurements. And in this page, we have some theory also, like what is continuous beam, what about the bending moment condition for the continuous beam. Everything has been given here. Beams placed on more than two supports are called continuous beam, that we know very well. Continuous beams are used when the span of the beam is very large. Deflection under each rigid support will be equal to 0. So in that case, we can go for the continuous beam. Definitely, the number of support will be more than 2. Next, objective of this experiment is to find the shear force and bending moment diagram for the given continuous beam section based on the various loading conditions. So this is our manual, in which we can note it down like what is the span of the member. Since we are going to analyze the continuous beam, right, definitely there will be a minimum of 2 span. So what is the length of the span and breadth, depth, everything, weight of the section. X means where we are going to apply a load, even it will be a central point load or non-central point load, whatever it is. Then these are all the two important column, the whatever the things we are going to observe from the animation, like bending moment and shear force values. Similarly, we can note it down the value for the all conditions, like one span central point load, another span non-central point load, both the span central point load, or one UDL and one point load. For various cases, we can note it down the value with the help of this observation table. The procedure also the same. First, we have to choose the continuous beam and span. Based on that, we are going to apply the external load. In this particular experiment, we can try various trials, like as I have already told, like one span with point load and another span with UDL. Similarly, we can go with some other trials. Okay, let us start with the trial. So for this, you have to click the flash view simulation. So in this simulation of virtual lab, these are all the category already pre-programmed. Two equal spans, again two equal spans. That means two equal span concentrated load at center, two equal span. This is concentrated load with the UDL, and two unequal spans. So first I am going to choose two equal span. So after choosing this, here is the option for concentrated load, and here is the option for uniformly distributed load. First, I'm going to apply a point load. So after applying the point load in the first span, automatically I can get the shear force diagram as well as bending moment diagram here. Now I am going to apply uniformly distributed load on the same span. Now you can see the shear force diagram and bending moment diagram for the corresponding. Similarly, we can choose two equal span. Now both the span of the section is equal, as well as the loading also symmetrical. Now we will check what is the shape of the SFD and BMD. So this is the shape. If the entire span is loaded with UDL, I'm applying UDL on the entire span. So this is deflection diagram, and this one shear force and this one bending moment. In case of two unequal spans, we'll check what is going to happen. So I have chosen two unequal spans. So see here, compare then the first span, the second span length is short. Now the first case, point load. So here we can see the magnitude of the load is same, but due to the span, there is a major impact in the bending moment diagram for the corresponding span. Compare then the first span, the second span magnitude value is less. Similarly for UDL, Here also you can note it down the magnitude of the UDL as a parabolic diagram. Definitely based on the span of the section, automatically the section bending moment value as well as shear force value is getting varied. So these are all the general idea we can able to get it. Before starting the structural analysis subject, definitely no one aware about how the shear force diagram will be, how the bending moment diagram will be. We know about the various category like starting from the cantilever beam, simply supported, continuous, fixed beam. Based on the three kinds of loads, automatically there will be a n number of cases. If the cantilever beam is loaded with a central point load or load with free, and obviously the shear force diagram will be located at the top of the section or top of the fiber, and bending moment diagram will be a bottom of the fiber with right angle triangle. So this is one condition. Similarly, there are many conditions, but definitely our student will get confused. So before starting into those kind of theoretical concept, we can get it into the virtual laboratory and we can show them how the bending moment diagram and shear force diagram is going to draw for the various kind of the sections as well as cases. After that, we can proceed with the particular problematic. In this particular virtual lab, I'll show the simulation for the simply supported beam also. See here, for all kind of beams, they have given the procedure as well as the general descriptions like what is simply supported beam, how the deflection or bending moment will occur. We'll see one more example. So this is for cantilever beam. I'm going to choose the cantilever beam at very first. See here, due to application of point load, you can see the section deflection, shear force and bending moment. And for UDL also, you can see in the right hand side. So these difference we can show our students virtually, like what is the implementation of point load as well as UDL. We can see here it's like a inclined straight line and it's like a little curved shape. Similarly for fixed beam also we can show it for point load as well as for UDL. And there is one more beam, it's nothing but propped cantilever. So this is the deflection, shear force and bending moment of a propped cantilever due to point load. And now it's due to UDL. Now two side simply supported beam, it's nothing but simply supported, both the end pinned or roller. So this is the diagram for shear force and bending moment, left hand side for point load and similarly for UDL. So here you can show the difference between the deflection of a simply supported beam for point load and for UDL. So point load, the magnitude will be less compared than the UDL. Obviously the deflection of the beam will very high compared than the point load in UDL, and these are all the shape for the corresponding. Similarly, we have few more experiments, not only beam. In analysis of the section, we are having like column. In column also you can show the different end conditions like both unpinned and one unpinned, one unroller. In all the cases, due to application of the axial load, you can show what is happening for the buckling effect of the column, how the buckling is going to happen. So I'm ready to show that also. With this experiment, I'll complete my animation. See here, there are various end conditions of a column section. After applying the axial load, you can see where the buckling effect is getting occur. So see here, due to the fixed condition, the buckling value is very less, but we are getting the crippling of the section at the end of the column. Hope everyone is clear about this. Is there any doubt? Thank
Okay, I
you.
think thank you, sir. Thank you. Kanaga ma'am, can we have
Yes,
yours now?
yes, ma'am.
Can start presenting, ma'am.
Okay.